Testing 1, 2. There we are. Yes, there we are. Hello. Let's turn the music that I am hearing a little bit softer. Right. So I put in the description what I'm going to do. I believe that this set index here is the actual set index that we require for each of the shader resources that we require. Nevertheless, set index here it's just being used to determine what is set index end, aka the largest set index that is needed or used. And all we are really doing here is creating the shader resources. Hi, King Mushi. Welcome back. So yeah, this function really only creates the required shader resources. After that, we call this function only once. And that function... Hey, Redden is also back. How are you? To the resources per set index. Resize. Yeah, I think it works. It's kicking out all the spammers. Not because they spam, but because they use too many symbols. Set key. Okay, here we also have the set index, which is then printed, and then we push back all the shader resources by required set index in the shader resources per set index vector. Okay, I think we're still pretty arbitrary up till this point, but then they are sorted. Maybe that makes a difference. But okay, I'm still sticking to arbitrary here. And this is our output vector. So if you read the description, this is the vector that must list all the descriptor set handles in the order of the set indexes that they should use or etc. The type of this thing is a vector of descriptor sets, right? sorted by set indexes. So the original problem was that if for a given set index there are more than one shader resources, and therefore the size of I was thinking this is a vector of vectors indeed. So this is a vector that also uses a set index as an index, and it stores a vector of shader resources. So for any set index there are multiple shader resources, then the size of one such element, which is a vector, has more than one element. It's so confusing how to say this. Smart people, my viewers, they know what I mean, right? Then the order of those shader resources for a given set index is still undetermined. I must say, it looks wrong. I would say you have to sort this vector. That's not possible. Well, not here anyway. Strange. Well, this is a vector of vectors. And we're running over it here. No, we're not. We're running over a given set index here. So one of the vector elements. And then we call lock on that. Yeah, seems like I'm sorting the wrong thing. Or I'm completely crazy. And how is that then working at all? What? Crazy. Makes no sense whatsoever. That makes no sense whatsoever. Running sort on this thing would require a less than for this vector, right? I'm not even sure I have that. It seems unlikely. Currently I'm not even understanding why this compiles. Can someone understand this? This highlighted thing here is a vector of vectors, and I'm running standard sort on it. That would order the elements that are vectors themselves, which means that it needs to compare one vector with another vector. And that should not compile, but this compiles. What's going on? It's really strange. I'm going to put a breakpoint here, I think, and step into it until I see a less than operator. This is so strange. Okay, file 583 is the line number. We have it compiles, and then I can run it in the debugger like which ubt nope. I had this in my mouse buffer, and I want to run gdb on this. Break 583. Okay, there we are on the sort. So, well, let's start stepping. That's gonna take a long time, I'm afraid, because it's not trivial at all. Set scheduler locking step. I don't know what happened while I stepped it, but currently we are in vector. Okay, it's inside this end now. It's not very interesting. I think I can do a list frame 0. List. Yeah, this it's not good with stepping when you have braces like this, right? If I step now, what happens? Oh, it's still, well, that's a step, yeah. I wanted to do a next. I don't think if I do a next, it's just bang all the way back. So we were inside this end. I do a next, and then we are here. That's not what you want a debugger to do. Stupid debugger. Well, continue. We'll get there again. Okay then. So step, 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 step. I guess at some point we need to, yeah, begin. Well, that wasn't too long then. So now we are inside this begin. That's probably also short. Cannot access memory address. What? What? What the? I don't think that should be happening. I would guess that it crashes if I continue. Let me try continuing. No, it's not crashing. It's just GDB being crazy. Yeah, let's run it again from the start. Yeah, King Mushy. Yeah, that was ./a.out. Godfoo. You have to be accurate. Accurate. A.out is what a test program that I compiled that faked the terminal. It's running cut with argument foo, and cut was thinking that it is a terminal, even though it isn't. It's being run from within my program. Standard sort step. Okay, we're going to step again, begin. Now we are in sort. No, we are, yes, we are in sort. Okay, I'm just going to step a bit. Iter less iter. Another sort. Cannot access memory at address 35. It's doing the same thing. This is a compare. Okay, it's comparing two things. I have no idea what this is, but I'm not seeing an operator less than. So what is it doing? It's using comp, and then we get here. It's using iter less iter. Comparing two iterators. Sorting by iterator. No. It's sorting the contents of the iterator. So where we jump to from here should be, this is my less than. Now I'm line 44, so if I now do step, line 45, there is my less than iterator. And when I do a step, I should get into it1, dereference. I have no idea what this is. Unspec. What? We go back here. I would say this is an iterator. 2 is standard vector containing base const pointers. Then we get allocator, which also knows about this type. So nothing else really interesting. And then we get operator star, so dereference. So this is the dereference function of an iterator to standard vector. That should return the standard vector. So this is going to return the standard vector. And then it's going to call a less than on that vector, right? Well, I don't know. Let's do S. Lexicographical compare. Oh, oh boy. Yeah, right. It's trying being smart. So there is a there is a spaceship operator for the vector. Yeah, that was not intended. Definitely not. So there's a bug. There's definitely a bug. I didn't. I was wondering mostly why it is compiling, but apparently there is a vector less than defined now. In wherever. For vector itself, by vector itself. Strange. And then that leaves us with the question, why did this even work? But probably because those vectors are so small that there's nothing to sort to begin with. Although, yeah, no, it's not really true. It's sorting something that should be sorted by set index. So I'm definitely like, I'm going to go to, I'm going to go for, rather, that we sorted the wrong vector. I should have been sorting this. The vector inside the vector. However, this is also not good. I mean, I don't even have a set index here outside of this loop. I think I have multiple vectors. So first, I could make it a set, but vector is always slower. Vector is always faster, so I really don't like to use anything else than a vector, unless we're talking about 10,000 elements or something like that. That's repeated a lot. I'm looping over shade resources a lot, and then I do these 3 lines a lot every time again. It's probably not slow or something, but it starts to smell like code duplication. So if I'm not using the set key, nor I'm using the set index hint, I might as well make a function that just returns a set index. No. Isn't that the case? Isn't that better? So let's say how often exactly am I doing this? In this file, and then what do I do with the set key? So in this case, clearly we are just making a set index of it. Here also, here less clear. We also make a binding number, but yeah, from the set key. And here also. Okay, so sometimes I also need the set key for binding. And this is, are we at the top again? Yeah, that was the top. So it's still limited to 1, 2, 3. 3 cases where I just need a set index, and then 2 cases where I also need a binding number. Yeah. I guess still limited enough-ish. I don't know. Let's concentrate on this. So I'm running over it again, and then I'm sorting. Now I have set index. I'm sorting all of them. Okay, well, at the very least, after this change, I suppose I should try to compile it and then maybe even run it to see if it still works. And it still works. Okay. It even works 3 times on a row. That's good enough for me. So okay, so now I have sorted them by the value of their pointer, but they are not sorted by set index, right? So say yeah. I don't know. Let's look at the next function. This gets the required set layouts per set index. Now I'm confused why this assert is here. I remember that I wanted to move it up and then move it back. This is a function that might be called more often than once. So why did I put it back in here? Is it that the canonical pointer might change? I guess. Yeah, maybe I did because I didn't want to pass the canonical pointer to the previous function. Doesn't really matter much. Okay, so here we are going to collect the descriptor set layout handles that of the descriptor sets that we are missing. And then at the same time, I'm also collecting the set index that each belongs to. So these set indexes are even more important. But the question is, where does this set index come from? And that set index comes from, well, just a hard-coded loop, I would almost say. Given set index, yeah, well, okay. So this only happens here, which is at the end of the loop of set indexes. So there is only going to be at most one set index of a given value in this set indexes vector. And these are, yeah, more or less still random order. So then, if it's not empty, I'm creating them. And then here the magic happens. I'm putting them in this vector that we have to create by set index that we require. Not all of the magic, because the problem was not the layout, but the problem was the shader resource. Yeah, so anyway, this vector is now filled with either missing or just allocated descriptor sets. Oops, allocated descriptor set was put in, well, it's copied here, created here, and then we put it in here. Of those set indexes and the set indexes that we skipped, they were assigned immediately. So these are existing descriptor sets, and we already have those assigned as well. So now this vector has a correct descriptor set handle for each set index. But if we reuse the set index, especially if we reuse it, I think it might go wrong. So if we reuse one, that is in this case, we're using some handle, and that handle has the shader resources bound to yeah, to the descriptor set that that handle is pointing to, which is done by another pipeline factory. And we need to know what that was so that we can fix things. Now, in order to know what it is, we are going to store certain information in the case that we create it. So let's follow that path first. If we create it, then the set index was added to set indexes. So this is, we push this, we push the layout handle into this vector and as well in set index in set indexes. Then we allocated descriptor sets using that vector. And for each of those, we just know that the set index also in set indexes. And then we have a loop below here. Here we run over all the required shader resources. And that cannot be correct. Okay, this is confusing the hell out of me again. Or does it make sense? No, it doesn't make sense. If you ask me, it does not make sense. Jesus, how can code work with so many bugs? The required shader resources list are all the shader resources that this pipeline factory created. But this loop is taking care of binding the descriptor set to a given shader resource. You could argue that we only need to bind it when we just created it, but that's not true. It's possible that the same shader resource has to be bound multiple times and is definitely only going to be created once. I'm thinking so hard apparently that it is 20.5 degrees Celsius here. It's ridiculous high. Is it that hot outside? Okay, so where were we? Yeah, this. No, I don't know. Let's look at that later. But it's definitely not good. So, one way or another, I'm running over all the shader resources again, and we know that what the set index that we want them to be in. And if this is the first time stuff got created, and we can find the set index. Can be found in the set indexes, which means that we just created the descriptor set. If we created the descriptor set, we're going to bind it as well. Oh, that's not a thing. Really? Okay, that's it. Yeah, and that's correct. But you only bind the descriptor set once. Well, not really, but in my code currently here. Just that we can bind different descriptor sets with the same shader resource eventually. Okay, so what is happening here? If we just created this descriptor set, then we do an update descriptor set using the, for the descriptor set corresponding to this set index, and we bind it to shader resource. So that's almost per definition correct then. This descriptor set is new, and the one that we allocated especially for this set index, that's this descriptor set. There's a descriptor set that was allocated for this set index. And I'm binding it to this shader resource with the correct binding number. So absolutely correct. But we must be able to find back what we did here later on. So I'm also calling this function here, which adds what we just did to the shader resource, so that another pipeline factory can find that back. And we do that as follows. We got layout, and then we store, well, the layout is stored in a pointer, canonical pointer, but it really stands for just the whole layout thing. And then we store in the shader resource using the layout and the binding as a key. The descriptor set handle that it was bound to. So apparently we're not storing what the set index is. So it should still be possible to go wrong, I think. difficult. How could this go wrong then? ID. Descriptor set. Yeah, well, maybe. You mean a graphical editor? I don't think I'm there yet. Required shader resources list. Why? I need to bind, and this loop is doing this one thing. That is what it's doing inside this loop. This is not doing anything, just collecting data. And what it's doing is binding. Now, of course, I have to bind if it is a new descriptor. But what happens if it's not a new descriptor? Oh, then it should already be bound. Yeah, okay. Do the same thing. Yeah, also correct, actually. It is already bound. So, okay, I think it's correct, right? Yeah. Um, What I really want is simply run over all the new descriptor sets, aka run over set indexes. Each set index can correspond to multiple shader resources. No, the bot is not really working. Nightbot. Can someone find out how I can add a rule to Nightbot that filters on the name? I mean, you can add, you can make a blacklist of things that people are not allowed to say, and then also search in the name. But if I would say want to kick them out because they have .xyz, then I would also kick everyone who says .xyz. Now, in this case, that's possible, but I can imagine that there are extensions, URL extensions that I do not really want to kick people on. Could take the full URL, I guess. I don't think they changed the URL a lot, this bot. So how does this read? Number of shader resources bound to descriptor sets equals shader resource count per set index. Well, let's use the same thing. Either or I have to change this to number of shader resources in this set index. It's maybe better, I don't know. Also plus plus, yeah. Say number of shader resources in this set index. Oops. Well, thank you, P256. I'm gonna start at the top again, but this time with in my head the fact that I need to eventually run over all shader resources. Yeah, that. are going to be bound to a new descriptor set. Pretty sure that's just all of them. In fact, I'm so sure I'm going to just replace that loop. Yeah, this is also funny. Run over all shader resource in reverse so that the first one that has VK null handle added, that's incorrect. It's now a log. And the log is called for the first shader resource. And the first shader resource is the first one in this loop here. What? No way. Really? Resource set index. And then we running over set indexes. And it's required set index. Okay-ish or not? Not okay. It's not okay. No, it's definitely not okay. This function is still totally wrong. It is wrong. It is totally wrong. Oh, okay. Okay. Required shader resources list is slightly different from what I thought it was. It is a more complete list. So that for loop is correct to run over all this vector, and it is sorted. It's also nice. I am highly confused, however. Yeah, I was confused with required. I call it acquired because I succeeded in getting the lock. And then here we unlock it again. Okay. Not too bad then, not too bad. Lost again. Have a quick look at the Nightbot stuff. Spam protection, blacklists, words. Let's add JIT 69. And also check the username. I'll make it silent. See if that improves stuff a little bit. Hello, normal Robloxian. Okay, let's forcefully make it fail, because I don't know why, but it is succeeding all the time. The only thing I'm not sure about if this is pure coincidence or that it is guaranteed, because I'm sorting those shader resources by pointer, and that, I don't know. Anyway, this just works, right? 2 triangles every time. I don't think it fails. So what if I'm going to make it fail in the way that I think it should fail? Occasionally, by chance. And what you have is 2 uniform buffers that have the same layout. Let's think, how can I make this go wrong? I think that the first time we get here, maybe I have enough debug output still to see what is going on, and we just look at the debug output. Prints a lot here. This prints also. It's about binding. Yeah, well, print stuff. So the first one has a non-identity for the set translation. The second one has the identity. Doesn't really mean that this one wins, but it is likely. So what it's doing is, yeah, it's definitely winning. For unknown condition. No, I have to fix that. AI muting is lock. I think it's just printing it. print conditions. It returns a conditions thing which has a print on, which well, 4 is a power of 2, so it's calling condition string implementation on pipeline factory, I think it is. And we have a pipeline cache setup. Yeah, never added these two. That's the 4. And we also have an 8. So we are here. This is the first time this function is called, and it's calling AI stateful task mutex log with create shader resources as the condition. And mutex is acquired, and then we do that 4 times for 3 uniform buffers and 1 texture. 1, 2, 3, 4, and they all succeed, right? Mutex acquired 1, 2, 3, 4. And because it acquired all the logs, it's going to create stuff. And this one is creating a create buffer. So I guess an uniform buffer, yeah, just there in front of me, uniform buffer. Right. Created object, pipeline factory, and top buffer. And then we're going to do that again, I guess. Uniform buffer create. Created the left buffer. Well, and so on and so on. Bottom buffer. Yeah, that worked a lot better. See, now they are immediately removed instead of after a long time. But only one was banned for 600 seconds and the other for 5. Maybe they did 2 things wrong in the eyes of the bot. It's, well, I don't see my texture being created, but I guess it is. It's not printing anything because the texture already exists. Then we get on this one. And Entering shader input data, initialize shader resources per set index. Running over all required shader resources, list shader resources. And we have sample texture, top buffer, left buffer, and bottom buffer. And the top buffer and the texture are in the same set. Set hint 0. The actual value is not even that important, just that they are the same. We'll mix them in the same set. And because of the non-identity translation here, we see that they're actually going in 1. And then left is not going in 1 but in 2, and bottom is going in 0. Well, I don't know. This one comes pretty close, but maybe the winner is either elliptic curve cryptography library or the memory model checker. Okay, this function here. You should just begin. Just begin. I'm not telling anyone to pick the language they want to code in. Yeah, D knows it. Should start with hello world. Okay, this function. It is not this function. This function. Entering sort descriptor set layout is entering x loop over set index 0 to 3. Set index 0. Entering loop over all shader resources. Shader resource is bottom buffer. Binding is 0. Shader resource corresponds with set layout canonical pointer at one that has a binding 0, obviously, and that is a uniform buffer. The hint is not taken into consideration, neither is the handle. Entering log set layout binding for that pointer and binding number 0. Entering log descriptor sets. Entering log. Mutex acquired. Not in progress. That's because we are the first one. Entering descriptor sets. Setting have match to false because still have match is false. Adding set index number 0 to set index because have match is false. Set index 1. It's going to do that with everything, I guess. Entering loop overall shader resources. Shader resource is sample texture binding 1. I guess it cannot find that. Okay, it's calling log. Mutex acquired, not in progress, which means that we have to create it. Adding set index number 1 also to set indexes. And we do the same thing with set index number 2. Adding set index 2. And now we have all the set index added. So now we calling entering logical device allocate descriptor sets. Getting 3 back. Now we're running over shader resources again. Shader resource bottom buffer. Set index was found in set indexes. That is, we just created this. We just created a descriptor set for it. Entering logical device, update descriptor set. Okay, we're binding it. Entering set layout binding. Add set layout binding, I mean. Scroll up too high. There is a lot of detail here. Maybe a bit too much. Okay, well, super uneventful because that was the first entry. And this is the second one. Yeah, what happened? What is happening now? This is triple one. Calling this function. Gets it kind of immediately skips creation and goes to the next state. Calling initialize shader resources per set index. And then we call that function. Sorted binding is binding 0, uniform buffer, comma, binding 0, uniform buffer, comma, sorted bindings, binding 1 is a combined image sampler, and binding 0 is a uniform buffer. Print it again, starting to loop over all the set indexes. The first set index, loop over all shader resources. Shader resources and left buffer, binding 0. Shader resource corresponds with set layout canonical pointer. Yes, binding 0 uniform buffer. Entering log set layout binding. Mutex acquired. Okay, that's definitely weird. Well, no, okay, this means not in progress, which is correct. Entering descriptor setting have match to false because still match is false. And why will that be? What the hell? Is it allocating new descriptor sets? It is. So much for working. I'm distracted. Okay, I'm eating so bad, which is not good for my health. It's now 1 hour past time that my computer said I had to eat, so I just have to eat. I'm gonna stop the stream and I'll be back after dinner.